functions. A commuter drove to work a distance of 20 miles and then returned again on the same road. The average velocity on the return trip was 10 miles per hour slower than average velocity on the outgoing trip. Express the total time required to complete the round trip t as a function of average velocity on the outgoing trip x. So now here we already know the rate is equal to the distance over time. So just write those formula first. And from here implies the time is equal with but let's write the time with a t, with a capital T, because here we have a capital T. And the time is going to be equal with the distance over the rate r, velocity. So r is the rate or velocity, here r. So now as we see here, the commuter goes from the home goes to work. Let's say it goes from the point A to the point B. Let's say here is a point B. And here is the distance, which is 20 miles, says. Here is 20 miles. The distance is 20 miles. Let me write it just 20 here, 20 miles. And here is the R1. But let's say R1 is equal with the x, because we don't know the velocity. It's not given. And then we have the distance from the work to home. So this is the same distance from this distance of B to A. And so distance is the same, is 20 miles. But what changes here changes the rate. Because of the velocity. Because velocity here says the return trip was 10 miles per hour slower than average rate. It means that this velocity here is r2 is going to be x minus 10. So it means 10 miles slower, so x minus 10. And now if we write here the time is required, so the first time, for example, to go from home to work, and time 2 is to come back from the work to home. So it's going to be equal, here the distance over R1 plus the distance over R2. And now we can substitute here those values. And if we substitute the values here for d, if we are, let's say we wanted to write this function with respect to x. And now instead of the d in the first part here, we are substituting the value, numerical value 20. And instead of the r1, we substitute it with the x. Here is a plus, and the second part here, d is 20, is the same, is a constant. Here is 20. When she comes back at home, is the same distance. And here, the r2 is equal with x minus 10, because the velocity is 10 miles per hour slower than it was when she went from home to work. And we can write minus 10. So this is the rational function that we can write in this case.